Hey, Honors Chemistry, do you miss me yet? So I wanted to talk about particle diagrams with density now. And remember, density is this unit of mass per volume. And the way that we represent mass is by the number of particles. And the way that we represent volume is the space those particles take up. So every time I draw particle diagrams, I have to encompass mass and volume. So let's say we're talking about liquid water here, because the density of liquid water is about 1.0 grams per milliliter. So let's say I have 10 grams of liquid water. If I want to draw a volume of space, okay, it doesn't matter what it is, let's say in this volume of space, I'll draw 10 grams as 10 particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my 10 grams of H2O, okay? And it's in a certain volume of space. Well, I should know that the density of water is 1 gram per milliliter. So if I have 10 grams of H2O, how many milliliters, or what's the volume of H2O? Well, technically, if I were to plot this on a graph, the equation for the line for density of water should be y equals 1x, or milliliters is equal to 1 times grams, or grams is equal to 1 times milliliters. Meaning my grams are essentially the same as my milliliters for water. So if I have 10 grams of water, I should have 10 milliliters of water. This box represents 10 milliliters. And so this is how, with particle diagrams, you're going to encompass this idea of density. I need to make sure I keep track of, okay, my number of particles, I have 10 of them, and this volume is also 10 milliliters. You're going to do that with other objects. You're going to make sure that the mass per volume ratio is constant, because it will be constant. My mass can change, and if I change my mass, I will change my volume. And you saw that if I change my volume, I might not necessarily change my mass, and that happened with ice. All right, but what if I kind of cut this in half? If I cut the matter in half, what's going to happen? So let me see. If I cut this in half, I'm going to draw like kind of two half. Right? If I cut it directly in half, this means that this will be 5 milliliters, and this will be 5 milliliters. Okay, if I cut it in half. You could also say same thing with grams, right? But I just went the 5 milliliter route. So if I cut it in half, if I cut my volume in half, right, I have 5 milliliters over here and 5 milliliters over here. How many particles must I draw in here to keep this ratio of mass to volume constant? Well, if I have 5 milliliters of H2O, I should still have 5 grams. Well, if I represented 10 grams by 10 particles, I'm going to represent 5 grams with 5 particles. 1, 2, 3, 4, 5. And the same should be over here if I have 5 milliliters. 1, 2, 3, 4, 5. Okay? But my question becomes, if I cut this in half, are the densities the same? And that's going to be a future test question, so star that. Well, density is mass per unit volume. I have 5 grams in here, and this is 5 milliliters, as I mentioned, because I cut it in half. The density is still 1 gram per milliliter, so yes. And basically, to answer that question, if I have the same substance, I should have the same density. Density is used to identify substances, and we're going to do that from now on. So, quick recap of this whole thing. Remember, density is a mass per unit volume. The way that I represent mass is the number of particles I put in here. The way that I represent volume is the space that it takes up. And sometimes I could change the space, or sometimes I could change the number of particles. Okay? If I cut that matter in half, I have to make sure that the distribution of that matter is the same distribution as the density tells me. Right? My density tells me that for every 1 gram, I should have 1 milliliter. So if I cut that in half, I should have 5 milliliters, which is going to be 5 grams. And 5 grams per 5 milliliter means the same density of 1 gram per milliliter. Now, what if I had two objects, right? And I'm going to make them like the same volume. And you'll see how I'm making them the same volume. These are the same volume, because the same space. Okay, and let's call this A, and let's call this B. All right, so these are the same volume. I put them within the same space. Let's call this volume 1 milliliter. I'm going to call this volume 1 milliliter as well. It's the same. All right, and now I'm going to draw a certain number of particles for A. Let me say I have 1, 2, 3, 4, 5, 6, 7. And I'm going to draw a certain number of particles for B. And I'm going to draw it with a different color because it's a different substance. So 1, 2, 3, 4, 5. I'm going to shade it too. Okay? Now, what is the same about both of them? All right, so let's talk about mass, let's talk about volume, and then let's talk about density. Okay? And you're going to see this on worksheet 3. Okay? So, as far as mass goes, between A and B, which is more massive? Well, remember, mass has to do with the number of particles. So which of these is more massive? Well, for A, I have 1, 2, 3, 4, 5, 6, 7 particles in a volume of space. And for B, I have 5 particles. So for A, I have 7 particles. For B, I have 5 particles. I'm going to say A is more massive. It has more mass. Okay? For volume, well, I already told you that they're in the same space of volume. They're both 1 milliliter. So I'm going to say the volume is the same. What would be the density of A? So A is mass per volume. Well, if I want to use my particle business, I have 7 particles per 1 milliliter. For B, I have 5 particles per 1 milliliter. Which of these has a larger density? Well, I'm going to go with A. A is more dense. Which means if I say something is more dense, if I say that, I say, what I'm saying is it has more mass per volume. When something is more dense, it has more mass per volume. If it's less dense, it has less mass per volume. And then typically, just as like a side note to help you out, less dense objects float in more dense objects. So technically, if I put particles B, if I had like a container, right, and I had A and B in here somewhere, right, all of my A particles would be at the bottom, and all of my B particles would be at the top. Less dense floats. Okay? And that's just an aside. So less dense objects tend to float or be more towards the top of matter. More dense objects tend to sink or be at the bottom of matter. Okay? So I'm hoping this last video is helpful and sets you up for understanding all of the content for the week. So a couple of things. Make sure that you know a couple of things. Make sure you know that if I give you a graph, the slope of the line, and this is mass, and this is volume. Make sure you know that the slope is equal to the density in grams per milliliter, right? So that's one thing that I want you to know. Another thing I need you to know is I could convert between grams and milliliters using the density. So make sure you know how to do that. Convert between grams per milliliter using the density. So if I know y equals mx plus b, and I figured out that my density is equal to 5.1 grams per milliliter, if I have y equals 5.1 x plus b, and b actually doesn't even exist, if it's y equals 5.1x, that means grams is equal to 5.1 times milliliters. And I could use this to interchange between grams and milliliters. If I solve for milliliters, milliliters is going to be equal to grams divided by 5.1, which means in general, grams is equal to density times my volume, and volume is equal to grams divided by my density. And when I say grams, I mean mass. Also make sure that you can use density to identify substances. Those would be the three big things that I would want you to be able to do when I return. Knowing that you could read a mass versus volume graph and the slope is equal to the density. Knowing how to convert between grams and milliliters using the density, right? And I kind of just showed you two quick equations. And then using the density to identify unknown substances. And then kind of like an aside thing is making sure you know how to do volume by displacement. If I put an object in a graduated cylinder in water, so if I have it at this level, let's say this is 50 milliliters, if I put an object in there and the volume rises to about 70 milliliters, I should, and I have the object kind of hanging in the bottom there, I should know that this difference of 20 milliliters means the volume of the object is 20 milliliters. Okay, so make sure you know these 3 or 4 things about mass, volume, their relationship, and density, and you should be all set for when we return on Monday. And then of course, in this video I mentioned about particle diagrams and drawing them. That's going to be a culmination of you understanding density. Can you put what we have learned about via videos, density, mass, and volume, and put them into particle diagrams? You will be tested on whether or not your particle diagrams make sense with mass and volume.